let's talk about synthetic division. So polynomial long division is great, and it's very versatile. You can use it in a lot of different scenarios, but there's this really cool trick called synthetic division, and it doesn't work for everything, but it works for a lot of stuff, and it's really, really neat and really, really fast. So let's look at this guy. We have 6x to the fourth plus 9x cubed minus 11x squared plus 20x, and our divisor is x plus 2. What's really important for synthetic division is that the divisor must be either x plus a number or x minus a number. So what won't work if you have 2x plus 1 as a divisor? That's not going to work. If you have x squared plus 1, that's not going to work because it's an x squared. It has to be x plus a number or x minus a number. So having a divisor of x plus 2 is fine. That's exactly what we want. So here's how it works. If this is a plus 2, you're going to go ahead and reverse the sign. So instead of plus 2, you're going to do negative 2. And I'm going to set mine up a little bit different than how Alex sets theirs up, but you'll be able to figure it out. Now, each of these coefficients, there's a missing x term in here, so I'm going to make sure that I remember that there is a plus 0x. Each of those coefficients, I'm going to come down and write right here. So I'm going to do 6, 9, negative 11, 0, and 20. I'm going to make a line right here before the last number, and I'm going to make a line here. The first step is dropping down this first number. From there, it's this number multiplied by negative 2. It goes right here. So drop the 6. 6 times negative 2 is negative 12. So I put negative 12 here. And then it's add down. So 9 minus 12, that's negative 3. And then negative 3 gets multiplied by this negative 2. So once again, drop down the 6. 6 times negative 2 is negative 12. 9 minus 12 is negative 3. Negative 3 times negative 2, that's positive 6. Negative 11 plus 6, that's negative 5. Negative 5 times negative 2, positive 10. 0 plus 10, that's 10. Just with my pointer, there we go. 10 times negative 2 is negative 20. And then 20 minus 20 is 0. This number right here is your remainder. And these guys right here are the coefficients of your quotient, and you start with 1 degree less than your dividend. So my dividend started with a degree 4, which means that the first term here is an x cubed term. So my answer is 6x cubed minus 3x squared minus 5x plus 10. And since the remainder is 0, I'm just gonna, that's my answer. I'm not gonna write plus 0 over x plus 2, but I mean, if you really wanted to, you could. Right. So really just as easy as that. I will do a few examples of it, but it's just like that. That is the process. So let's do another. We have 5x to the fourth plus 11x cubed minus 10x squared plus 2x minus 6 all over x plus 3. We're not missing any powers of x here, so we're free to go straight into our synthetic division algorithm because this is an x plus a number. So I'm taking the opposite. This says plus 3. I'm going to take negative 3. And you're always using your divisor for that. So I have 5, 11, negative 10, 2, and negative 6. I am getting those once again, this 5, this 11, that 11, negative 10, 2, negative 6, and drawing a line right before that last number. Your algorithm always starts with pulling that first number down, and then it's 5 times negative 3 is negative 15. 11 minus 15 is negative 4. Negative 4 times negative 3, that's going to be 12. Negative 10, oops. Ooh, what did I just do? 12. Negative 10 plus 12, that's going to be positive 2. 2 times negative 3 is negative 6. 2 minus 6 is negative 4. Negative 4 times negative 3 is positive 12. Negative 6 plus 12 is positive 6. My original polynomial started with a degree 4, so my quotient is going to start with a degree 3. So 5x cubed minus 4x squared plus 2x minus 4 plus 6 over x plus 3. Because remember, this guy right here is the remainder. Bam, easy as that. So let's just do one more for good measure. All right, so with this guy, x to the 5th minus 1 over x minus 2. So let me just talk about the missing powers here. So we are missing an x to the 4th, we're missing an x cubed, we're missing an x squared, we're missing an x, and then we have the minus 1 all over x minus 2. So looking at the divisor, it says minus 2, so I'm going to use positive 2 on the outside of my algorithm. This x to the 5th has a secret 1 in front, so I'm doing 1, and then let's see, we have 0, 0, there's 4 zeros, 4, and then a negative 1. Pull the 1 down. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. 0 plus 8 is 8. 8 times 2 is 16. 0 plus 16 is 16. 16 times 2 is 32. Negative 1 plus 32 is going to be 31. So our answer, so we started with an x to the 5th, which means our answer is going to start 1 degree less, x to the 4th. So 1x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16 plus 31 over the divisor x minus 2. That's it. I mean, can you imagine how long this would take you if you did long division? I mean, like, we could just do it. Let's just try it real quick. X to the 5th plus 0, x to the 4th plus, 0, x cubed plus 0, x squared plus 0, x minus 1. Just even me doing it quickly, I have x to the 4th, so it's like minus x to the 5th plus 2x to the 4th. Right, you can see, maybe I won't even do the whole thing. I mean, you can see exactly how long this is going to take me to do, right? Plus 2x cubed. I mean, this goes on for quite a while. Look at all of these guys here. So this whole process with long division would be excruciating. I'm not going to put us through that. That would be just too much. Actually, I'm going to pause it, go through the long division, and then unpause it so that you don't have to watch me do it, that you can just see it. So hold on just a second, let me do it. All right, there it is. There it is. So yeah, you don't want to have to go through that. That's terrible. That whole thing is terrible. Look how fast this was. Whereas I had to pause it so that I could write all this down and not bore you guys. So when you can use synthetic division, and again, it is important that you have a divisor that works, when you can use it, it's so worth using it. And there's going to be times later on where it's really, really useful to use synthetic division, especially as we go to talk more about polynomials and their zeros. So hopefully this made a lot of sense. It's something I personally I'm enthralled with this algorithm. I cannot believe that somebody came up with something so succinct and so wonderful. I think it's just great. Hopefully you enjoy it just as much. Good luck with your problems.